Hi, my name is Jana Luisa Monquiton, and today I will be discussing about exponential functions. Okay, first you must make sure that the base is the same, and then after that you would proceed next to the exponents. 2x minus 5 is equal to x plus 3. So then you would transpose the like terms. 2x minus x is equal to 3 plus 5. 2x minus x is x, equal to 3 plus 5 is 8. So that's how you would get the x of the exponent. The next part of my topic will be vertical translation, wherein the solution is b raised to x plus or minus c, wherein c is the constant. We've set the values of x into 0, 1, and 2. So to solve the values for y, we must substitute x with the first value of x, which is 2 raised to 0. And when we would disregard the plus 2, and as we go on, we would get the value of 1 and then this. Now let's move on to solving this group of points. First, let's substitute x with 0. 2 raised to 0 is 1, plus 2 is equal to 3. Stop. Now let's proceed to plotting the points. Let's first plot x and y. So x is 0 and the y is 1. Next is 1. The x is 1 and the y is 2. Next is 2. The x is 2 and the y is 4. Now we will move on to plotting the x and the 2x raised to 2. So first, 0 is x, 0, and then the y will be 3. Next point is 1. The x is 1, and the y would be 4. And the last one is the x is 2, and the y would be 6. 1, 2, 3. In vertical translation, when the constant is greater than the next graph would be 2 points higher than the original graph. As we can see, this is the original graph, and this is the 2 points higher. Now let's proceed to horizontal translation, wherein the equation would be f of x is equal to b raised to x plus c. The constant would be on the exponent. Let our first example be 2 raised to x plus 2, wherein I use the same values of x as I did on the first part. Now, as you can see, I have already substituted x with the first value, which is 0. Now, let's solve for the value. 2 raised to 0 plus 2 would be 2 raised to 2. 2 raised to 2 would be equal to 4. That will be the first value for x plus 2. And now let's proceed to horizontal stretching. Horizontal stretching has the equation b raised to x times c. Let c be the constant. First example is 2 raised to x times 2. So our x values are 0, 1, and 2. And then as shown in the first few topics, we all know how to solve for the value of y and the value of 2 raised to x times 2. So now let's proceed to plotting the points. Let's first plot the values of x and y. Let this be the original plot. So first is 0, the y is 1. Next is 1, the y is 2. And last is 2, the value of y is 4. And now let's plot the value of x and the value of 2 raised to x times 2. X is 0, value of 2x, 2 raised to x is times 2 is 1. 4 pala. The value of x is 0, and the value of 2 raised to x times 2 is 1. Next, 1 and 4. And last, 2 and 16. So the difference between horizontal stretching and horizontal shrinking is the constant. In stretching, the constant is always greater than 1. But in shrinking, the constant is less than 1 but is greater than 0, which means the answer must be a fraction. And now let's proceed to vertical shrinking and stretching. Let our equation be c times b raised to x. So first example is 2 times 2 raised to x. As you can see, I have already solved the values and I have already plotted the values for x and y. So now let's plot the values for x and the value of 2 times 2 raised to x. First, the value of x is 0 and the value of 2 times 2 raised to x is 1. Next is the value of x is 1 and the value of 2 times 2 raised to x is 4. And lastly, the value of x is 2 and the value of 2 times 2 raised to x is 16. In shrinking and stretching, the values share the same home point, which is 0 and 1. And the same rules applies to vertical and horizontal shrinking and stretching, wherein in stretching, the constant is greater than 1, and in shrinking, the constant is less than 1 but is greater than 0.